This video is about polygons in the coordinate plane, and we will be graphing points that make up a polygon and trying to figure out what kind of polygon it is, and we will also be looking at some characteristics about these polygons. Okay, but first I wanted to review quickly some of the tools we have when dealing with graphing. Okay, the first one is about the distance formula, finding the distance between 2 points. Now again, we can use a formula or a graph, and I'll first do the formula. It's the square root of, let's see here, I'll call this one x1, y1, x2, y2. And so x2 is going to be 4 from this 4 minus 0 squared plus y2, which is 4 from this 4 minus 1 squared. And that's equal to 4 minus 0 is 4 squared plus 4 minus 1 is 3 squared. Or I get the square root of 16 plus 9 is equal to the square root of 25, which is equal to 5. Okay? Now, I can also use a graph. Okay, so let me graph these points. 0, 1 is right here, and 4, 4 is right here. Okay, so I'm going to draw in a right triangle, okay, and use the Pythagorean theorem, okay, where this is 4 and this is 3. So to find this, I'm going to use a squared plus b squared is equal to c squared, and I'll call this one 4 squared plus 3 squared is equal to c squared, or 16 plus 9 is equal to c squared, or 25 is equal to c squared, or c is equal to the square root of 25, and c is equal to 5. Okay, so you can use either one, the graph or the formula. I tend to use the graph when I have a graph and the formula when I don't have a graph, because that just seems easier to me. Okay, but notice the similarities between them. This 4 comes from this change in x. Okay, and this 3 comes from the change in y. Okay, so there is a huge connection between these two. As I said before, the distance formula comes from the Pythagorean theorem. Okay, the midpoint formula. Again, I'll do it with a graph and with the formula. So in the formula, again, x1, y1, x2, y2. And I have x1, 0, plus x2, 4 from this 4, over 2, comma, y1 plus y2, which is from this one, over 2. And I have 0 plus 4 is 4 over 2, comma, 1 plus 4 is 5 over 2, or I get 2, comma, 2.5. Okay, on a graph, here's the point 0, 1 and the point 4, 4. Okay, you can kind of draw on the line and look for what would be right in the middle. And I kind of look, this length is 4, which is an even number, so I go halfway in between, it's about right there. That's more of kind of an estimation. The formula is probably a little more exact for that method, but it's a good quick way of doing it if you already have it graphed. Okay, the next one is the slope formula. Again, x1, y1, x2, y2. The slope is equal to y2 minus y1. I'm sorry. The next one is the slope formula. And again, I'll do it on a graph and an equation. So this is x1, y1, x2, y2. And the slope is equal to y2 minus y1 over x2 minus x1. And I get 4 minus 1 is 3, over 4 minus 0 is 4, and I get a slope of 3/4. Okay? Now to me that's just as easy as doing it on the graph. I have a slope of 0, 1, and a slope of 4, 4. Okay, and the change in x is 4, the change in y is a positive 3, and so again it's rise over run. And so it's 3 over 4. Okay, that was a quick summary of some of the tools we have in graphing. Okay, now let's use that. The question is triangle ABC scalene, meaning all the sides are different lengths, isosceles, two of the sides are the same length, or equilateral, where all three are the same length? Now looking at this, I can tell that length AC is longer than the other, so it's not going to be equilateral. But is it isosceles, meaning are these two the same length or are they different? I can't really tell just by looking at it. So I'm going to go ahead and use the distance formula to find the lengths. Okay, and since it's graphed, I'm going to use the Pythagorean theorem method. So to find AB, kind of draw on this right here, this length is 3, this length is 4, and so this right here, a squared plus b squared is equal to c squared. It's 3 squared plus 4 squared is equal to c squared, or 9 plus 16 is equal to c squared, or 25 is equal to c squared, and c is equal to the square root of 25, or it's equal to 5. Okay, now I'm wondering if BC is the same length, or longer, or shorter. Draw on those. This is going to be 4 in green, and this distance will be 3. Okay, now they're similar numbers, which makes me think it's going to work. So this is, I'll kind of be a little shorter this time, 3 squared plus 4 squared is equal to c squared. That 9 plus 16 is still 25 is equal to c squared, and c is equal to the square root of 25, or 5. And it is the same, okay? So these are the same length, and it is isosceles. Okay, hopefully you can see how the distance formula is used to answer that question. Okay, is triangle ABCD a rhombus? Okay, again, we can use our tools of the distance formula to find out if all 4 lengths are the same. Okay, and I can't tell just by looking at it, so I actually need to do the formula. So I'll start off with, let's see here, AB. This length is 1, 2, 3, 4. This length is 2. And so this length right here must be 2 squared plus 4 squared is equal to c squared. 4 plus 16 is equal to c squared, and c is equal to the square root of 20. And I'll just leave it there. I could simplify it some more, but I won't. BC is up 1 and over 1, 2, 3, 4. Okay, those are different numbers, which makes me think it's not going to work. And I get this. I get 4 squared plus 1 squared is equal to c squared, or 16 plus 1 is equal to c squared, and c is equal to the square root of 17. Okay, now these are different numbers, which means it's not a rhombus. No, because all the sides are not the same length. Okay, the directions are to graph and label each quadrilateral with the given vertices, then determine the most precise name for each quadrilateral. Okay, so I'll simply graph them and then try to figure out which quadrilateral it is. These are pretty simple once you graph them. 1, 2, 3, 4, 5, 5, 0, negative 3, 2, 3, 2, 5, 0. 1, 2, 3, 4, 5. Okay, if I draw this in, it looks very much like a trapezoid because these are parallel, and these look to be about the same length, and I could check it because it's over to, up to, and over to, up to, so it's the same. And it's an isosceles trapezoid. Okay, the next one. Graph and label each quadrilateral with the given vertices, then determine the most precise name. So negative 1, 1, 0, 2, 1, 1, and 0, negative 2. Okay, now these are the same length. Okay, and these look to be about the same length, so it must be a kite. A kite is shown at the right. What is the most precise classification of the quadrilateral formed by connecting the midpoints of the sides of the kite? Okay, so when you find the midpoints, this one right in the middle looks to be about right here because it's over 2, up 2, over 2, up 2. For this one, it looks to be about right here because I'm going down to over 4, down to over 4. This one is right here, so I'm going down to sorry, over 2, down 2, over 2, down 2. And here it's right here. Okay, so I have those 4 points. Let me clean this up a little bit. Okay, and I'll connect these. And since all the lines are horizontal and vertical, it's easy for me to see that these are all 90-degree angles. And it's clear that this is shorter than this, so it's not a square, it's a rectangle. Okay, now the trick is, well, we will just be graphing these and looking at it, and usually you can tell just by looking at it what type of quadrilateral it is. And if you need to check, like that very first one with triangle ABC, then you would use the tools you have, like the distance formula or the slope formula or the midpoint formula. Okay, so this video was about polygons in the coordinate